Okay, for our second question, we are looking at mixtures, and they give us a nice table. So we have our concentration of the solution in our first box. Then we have the amount of the solution in the second box, or second column. And then we have amount of acid. In the third one. Okay. So I'm going to fill this in with what is already in there. And 21%. Okay, so what we're doing here is we're trying to figure out how many liters of one solution that is 15% acid and another one which is 33% acid, how much of those should we mix together to make 40 liters of a solution that has 21% acid. So we have X and Y already kind of laid out for us. X would be the amount of the 15% solution, Y would be the amount of the 33% solution. And if we look at our table, if we're adding just the X and Y together to get 40 liters, then we can use the equation X plus Y equals 40 liters, because we want our end solution to be 40 liters. Now we can go in and fill out this rest of this column. So for our 15% solution, if 15% of the total amount is acid, then we could write that out as 0.15 times X. So times the amount of solution. That is how much is going to be acid. So in our bottom one, we're going to do the same thing, but this time it's 33%. So 33% of whatever amount of solution we have there, the Y, is going to be how much acid we have. And then in our third column, 21% of 40, we can actually work out the number. 21% of 40 liters means that 8.4 liters of that 40-liter solution is the pure acid. So we have one equation set up. We can look at our last column for the amount of acid. The 0.15x plus 0.33y has to be equal to 8.4, because the 0.15x is how much actual acid is in the first solution, and then the 0.33y is the other amount of acid that is from the second solution. And those are the only two places that our acid's coming from, so they have to equal 8.4. They have to equal the total amount in our end solution. So now we have two equations, and we can solve this either with elimination or substitution. There's no real easy way to just multiply one of the equations to set it up for elimination. So I would do a substitution. Over here, I can solve for X by just subtracting Y from both sides of my equation. So I could rewrite that as, this to be in red. I can rewrite this as X is equal to 40 minus Y. Very similar to what we did in problem 1. So if we know that X is equal to 40 minus 9, we can substitute or replace the X in this equation with 40 minus 9. So we're going to rewrite our second equation as 0.15. Instead of times X, we're substituting 40 minus Y. And we need to put that in parentheses so that we make sure to multiply all of it by the 0.15. So we write out the rest of our equation. 0.33y equals 8.4. Now let's start solving for y because we have an equation where we only have one variable, so we can finally get an answer. We are going to distribute the 0.15. So 0.15 times 40 is 6. So 6 minus 0.15y plus 0.33y equals 8.4. All right, I'm going to try this extend page. Oh, there we go. All right, so we have 6 minus 0.15y plus 0.33y equals 8.4. We're going to combine our like terms. So we can combine negative 0.15y with positive 0.33y. We get 6 plus 0.18y is equal to 8.4. Now we're going to subtract 6 from both sides to start getting y by itself. We get 0.18y is equal to 2.4. So our last step for y is to divide both sides by 0.18 so that y is by itself here. And 2.4 divided by 0.18 is 13.33333 repeating, which is the same as 13 1/3. So that's how much of our 33% solution that we need to use. But we still want to know the answer to how much of the 15% solution we need. So if we go back to our earlier equation up here, we knew that x plus y is 40, so we can figure out x by doing 40 minus y, now that we know what y is. So our x is equal to 40 minus 13 1/3, which is 26 2/3. So that is the answer to number 2.